Okay, so we are now ready to start talking about electric fields. Okay, what we understand is that if we have a charge, okay, let's say some particle carrying some charge q, okay, then just by having this particle, just by having this property of charge, creates something called an electric field around itself. Okay, now what we know is that if the charge is positive, then the field can be represented by field lines, electric field lines that point radially outward from the charge. Okay, on the other hand, if we had a negative charge, then these lines would point into the charge. Okay, now what we also know is the fact that the electric field at any point is equal to limit as some test charge approaches 0, okay, the force on the test charge divided by Q0. So this essentially gives us the way of finding the electric field. Now for a point charge, okay, the electric field is equal to, and let's find the magnitude simply, is going to be equal to limit as Q0 approaches 0. Okay, the force at a charge Q, so let's say I have a charge capital Q and I exert a force on some charge Q0 separated by some distance r. What do we know is equal to KE Q times Q0 divided by r square, and all thing this has to be divided by Q0. So what we know is that the electric field has a magnitude of Ke times Q divided by r square. So this is the electric field due to a point charge, and this gives us the magnitude. And what we know is that the direction is very simple. It is away for a positive charge or towards the charge for a negative charge. Okay, let's take a simple example and let's make sure we understand this. So let us say that I give a charge of value 5 microcoulomb and we have some point P in space that is at a distance of 3 meters from this charge. Okay, we ask, find the electric field. What is the magnitude and direction of the electric field at this point P? Okay, so to find the magnitude, you will use simply the equation KEQ over r square. So KE is 9 times 10 to the 9 times Q, which is 5 times 10 to the minus 6 divided by 3 square. And if you do this correctly, you'll end up getting 5,000 newtons per coulomb. Those are the units of electric field. The direction, okay, is very simple. What you need to do is sit at the location of the point. So if you're sitting right here, you ask yourself, what is the sign of the charge? If the answer is positive, then you know you're supposed to go away from the charge, which is what is happening in this case. If instead the 5 microcoulomb was negative, then you'd be going towards it, and so the electric field would be pointing to the left. So the direction is simply to the right. Okay, so make sure you keep this in mind and understand this. Alright, great. In the next video, we'll explore more about calculating electric fields, and then from them also calculating forces and other things.